Okay, so we're going to do today something called loop circuits, and unfortunately for you guys, we're going to be using more, not integrals this time, but this time linear algebra, to be solving some equations with multiple unknowns and things like that. Okay? So we learned that we can have a circuit with one voltage source, but unfortunately, fortunately, because it's such a great idea to use it, to use it for different things. But unfortunately for you guys, since it makes the math a little bit more complicated, there are very little circuits that only have one voltage source. So now we're going to start looking at the circuits that have multiple voltage sources. And they'll be on different branches of a parallel circuit, so you can't necessarily use the logic that we used last class when we were talking about the light bulbs. And this whole idea is called loop circuits. All right, there are going to be problems on Moodle for you to practice these. They could be quite long, but we're gonna do the short versions, and hopefully it's just the same process for the longer ones. You just have, instead of having a 2 by 2 matrix or a 3 by 3 matrix, you might have like a 5 by 5 matrix. But you guys should theoretically know how to solve that, right? Theoretically. All right. So let's get in it. They're called loop circuits. And you need to, the whole idea behind this is to be able to measure the current and the voltage going through every single resistor and circuit every resistor in a circuit. You should be able to measure their resistance, you should measure their current, you should measure their voltage. So this is what I mean by that. So in this case, you can see in this example circuit that there's two voltage sources, right? Here and here. And we just need to know by convention that this is its plus and that's its minus. Same thing here, same plus and minus. All right, and they're contributing differently in these circuits. Adobe Connect. Let me do that now. All right, there you go. You should have it now. All right. All right. So, so this is what we're going to be. This is what we're going to be solving, and we're going to need to know what's the current passing through this resistor, what's the current passing through this resistor, and based on this drawing here, what do you think is going to happen? Because look, this battery is going to send the current this way, and it's going to split that way, and you're going to have a current going this way, and it's going to split this way and that way. So what do you think that the current at this point, it can't be going in two directions? What do you think the net current in this direction is going to be based on the batteries? What would you guess? Is it going to the right or to the left, Shani? Yeah, absolutely. So it's a good guess, and we don't really know until we do the calculations, but assuming that this is 28 volts and this is only 7 volts, then you can say that there's probably a bigger current going in this direction versus the one coming in this direction. But this one might decrease that one's current a little bit. So those are the kinds of analysis that we're going to do. All right. So in the circuit involving one battery and a number of resistors, it's pretty simple. We know how to do that. You can use Kirchhoff's law. It's Kirchhoff's voltage law and Kirchhoff's current law. And in order to solve this one, when there's multiple voltage sources, we're going to use something called Kirchhoff's loop rule. Okay? And the basic law is that the voltage drop across a whole loop is the voltage. If you add up all the voltages in a loop, you'll get a voltage of 0. All right, so the voltage in a loop is 0 volts. All right. So what I mean by a loop, well, let's look at this simple circuit here.
I have one loop here with current going maybe in that direction, and current going here with currents going maybe in that direction. All right. And this is loop 1, and this is loop 2. And within one loop, if you add up all the voltages, it should give you 0. That's what Kirchhoff's loop rule is. Okay? So adding up all the voltages in L1 should give 0. And the same thing for loop 2. All right. It's strange because I'm saying you're adding up all the voltages, but what I need you guys to remember is that the battery, is it going to contribute voltage or is it going to use the voltage? What is the battery doing in this case? Is it providing voltage or is it using voltage? It's providing it. What about the resistor? Here, this resistor, is it providing voltage or is it removing or using up the voltage? Using up the voltage. All right. So we'll see. We'll have that. We'll add 7 volts, and then we'll drop a few volts, and we'll drop another few volts, and then that'll complete our loop. And that loop should give us a total of 0 volts. Okay? So first thing to do in order to solve one of these problems is to identify your loops. That was the first thing I did. I drew my loops, L1 and L2, and you can see that in this diagram we've done the same thing. We've identified what the loops are. In this case, they're called meshes. It's the same thing. We're saying that this is one mesh, this is another mesh. Okay, or that's one loop and that's second loop. All right, there they are. We're going to say that in each loop, there is a different current. We're going to call these currents I1 for loop 1, I2 for loop 2, I3 for loop 3, and so on and so forth. So here I had 2 loops. The first one I call them left, and the second one I call them right, and they're going to be 1 and 2. My question to you is, how did I know which direction to send my current in? Why did I draw a loop in this direction, whereas I could have drawn it in the other direction? That's a very arbitrary thing that I did. Bronley. Say that again. The current goes from positive to negative. Okay, sure. What if there was 2 batteries in there that were kind of like canceling each other out? In reality, it doesn't matter at all which direction you choose the loop. Okay, but you have to make a decision. All right, you can't not give it a direction. You just give it one, and it'll work out. It doesn't matter if you chose clockwise or counterclockwise. The answer will still work out. Okay, but if the point is that when you draw it with a given direction. Okay. Yeah. Wrong. Nope. They can be totally independent. Okay. So just the loops, the direction of the loops, they're going to be kind of arbitrary. You decide them, kind of like Gaussian surfaces. Remember those? All right. So here's some of the sign conventions that we need to learn. So now you've established a loop direction, all right? And you can see here that there is a voltage going across the resistor in this direction, all right? If it's going in this direction, right, that means you have a positive current multiplied by the value of that resistor, okay? That's confusing, but let's contrast that to this, all right? I'm going to cross this out because I have a more simple way of thinking about it. If you were to talk about this loop, if we're having a loop that's going in this direction and I'm analyzing this loop like this, okay? My current is going in this direction, so that means I'm going in the positive I1 direction because I'm going with the direction of I1. So my voltage is going to drop across I1, right? When you have a current that goes through a resistor, the voltage drops. So it should be, if I want to find the voltage that's dropping on this one, so I'm going to call this VR, it's going to be equal to negative I1 times R. All right? That would be the voltage drop across this resistor. I'm not done yet though, because look, there is another current that goes through that same resistor. So that means I have to, and oh, look at that, it's going in the opposite direction of the one that I'm calculating for. So I said that the loop's going in this direction, but in my other loop, I said it was going in that direction. So this, instead of it being a voltage drop, is going to be a voltage gain. All right? So I'm going to do plus I2R. Plus I2R. Yeah? Yeah. It's not going to be an absolute value. The current is going to be either a positive or negative number. The positive and the negative will determine if you correctly chose the direction. So if you correctly chose it, it'll be positive. If you incorrectly chose it, it's going to be negative. Simple as that. Okay? So let's try to do this. It's long, but we can do it. All right? We won't use linear algebra to solve the first one. We'll just use it with regular algebra, which is linear algebra, but not the way, like not using matrices. So here I'm going to decide on my two loops. All right, so how many loops do I have here? Two? Yeah, okay. I'm just going to draw them in this direction, like this. And this one I'm going to draw like this. I'm going to call this one L1, this one L2. And therefore, this loop is going to have a current I1, and this one's going to have a current I2. Okay? So I'm just going to skip over to the next slide because I'm going to have more room. You guys don't have this slide, I don't think. I just added it so that I have room to make some calculations. So again, I'm going to draw my loops like that, like that. This is going to be I1, this is going to be I2 for loop 1 and loop 2. So if I were to look at loop 1, okay, that's the first one we're going to analyze. We have a voltage gain, I'm just going to make it bigger. We have a voltage gain of 1.5 volts. And then a voltage drop across here and a voltage drop across here. So let's draw that. So we have a voltage gain of 1.5 volts minus the voltage drop across R1, which is 4 ohms. So it would be 4 ohms multiplied by the current. So 4 times I1. I subtracted it because it's a voltage drop. Same thing with R2. It is a voltage drop. So it's going to be minus, this time it's 6 ohms, multiplied by I1. But look at this. This resistance, this R2 resistor, which is 6 ohms, we said it's going in this direction, but in our other loop, we said it's going in the opposite direction. So what we're going to do is we're going to add R2 times the current there. Because remember that I'm using Ohm's law. Are you guys noticing that? To find my voltages, this is resistance times current, that's Ohm's law. Resistance times current, Ohm's law. So here I'm doing plus 6 ohms multiplied by I2. And that brings me back full circle around this loop back to the original. So all that should be equal to what? 0. That's loop 1. Let's clean it up a little bit because look, I have two I1s and I want to put all my variables on one side and all my constants on the other. So it's going to look like this. It's going to be negative 10 I1 plus 6 I2 is equal to negative 1.5 volts. Okay? I just cleaned it up a little bit so that I combine my I1s I put all my variables on the left side, so I1 and I2, those are variables. I put them on the left side, and my constants on the right side. Now we can do the same thing for loop 2. Oops. Loop 2, I start off with a gain of 3 volts. Right? So I'm gaining 3 volts here. Then I'm dropping whatever that is, but I'm also gaining that because that one's going in the opposite direction. So let's talk about the R2. Whoa. So R2 is going to be, it's going to be minus 6I2 plus 6I1. And then I have another voltage drop of R3 across R3. So it's going to be minus 3 I2, not I3, but I2. All that's going to be equal to 0. And again, let's clean that up a little bit. So we have 6I1 minus 9I2 is equal to negative 3. So check it out here. I have one equation with 2 unknowns there and another equation with 2 unknowns there. So I can solve this using a system of equations. I can use substitution. I can use whatever. Because you guys are in linear algebra, let's try to solve it that way. So if we were to rewrite this as a matrix, it would be minus 10, 6, and 6 minus 9. With a line there equals to minus 1.5 and minus 3. And that there is your matrix. Okay, so these are your I1s, these are your I2s, and you can solve it that way. Did you guys go ahead and solve that? It doesn't have to be the matrix way. You can solve it with 2 equations of 2 unknowns if you think that's faster. Whatever works for you, okay? So do that. I'll give you guys 5 to 10 minutes to work on that. Try to figure out how to solve that equation, okay? So I got a current for I2 equal to 0.72 amps. Let me know if I made a mistake. It's very possible. I did make a mistake? Oh, you got it? Okay, great. And if I were to now solve for I1, I just need to plug it in. So it would be, let's try this one. So 6 times I1. Damn it. Minus 9 times 0.72. Minus 2. Does it sound like you guys going for I1?
I got, well, I got this and this. I got 7 divided by 12, which is this.
That's for I1?
Yeah.
And you got 13 over.
Which is 0.72.
Here you got it.
What are we on round 2?
Well, we both got the 7.7.
Yeah.
So I'll ask other people what they got. Let's see, I think you solved your, okay, perfect. All right, so the answer is going to be 0.72 amps and 0.58 amps for I2 and I1. Now the hard part, whoa, what's going on with your screen there? Is that happening with you as well? Nope. Okay. Weird. It's the hardest, again, it's like when we were doing like the integrals and stuff, the hardest part here is setting up the equations. After that is just a bunch of math for you to solve the answers. So I want to practice setting up the equations. Let's do the same thing for here, all right? Except here, there's something new that you haven't seen before, okay? The new thing that you haven't seen before is that there is an amp source, an amperage source. Okay, this is not an ammeter, it's an amperage source. And this amperage source is providing 3 amps of current. So try using that. Let's try to set up the equations. Okay, we don't need to solve it. We just need to set up the equation. So first thing that you're going to need to do is establish, you're going to establish some kind of, what do you call it? Loops. So pick a direction. I'm going to go in this direction and this direction. How does this work with the amperage source? Let's ignore that for now, actually. Let's solve this problem without the amperage source. Because this one's actually not as simple as I thought it was. So remove the amp source. Just set up your equation. Yeah. Okay, and I'll give you guys this source here. It's going to be 6 volts. So we're just finding I1 and I2, and we're not going to look for this difference in potential across the unit. basically two equations there. Just make sure you get something similar to it. These two are going in the same direction. This I1 and I2 are going in the same direction for this resistor here. That means that it's a voltage drop for both cases. So when you consider it, that's why I did minus 2I1 minus 2I2. If I had chosen this to go in the other direction, I would have done minus 2I1 plus 2I2, right? Again, I'm not asking you to solve it. But here's what we're going to do. We're going to do this one. All right. I want you guys to consider this an assignment. And I'm asking you guys to do this within, let's say, 40 minutes. All right. In groups of 2 only. And in 40 minutes, hand it in, and we'll move on from there. Okay. I want to see all your work. I don't really care about the answers. It's your work that I'm interested in. You look so happy. Oh, okay. Got it.